On opener 19, now we have an equality, and we're trying to figure out how do we graph the following relationship. Well, you'll notice that of the areas. And so you'll notice that square root of y times square root of y is the same as square root of y squared, which is just y. So here the area is y. So we have y equals something, and we're trying to figure out what does it equal and how do we graph it. Because remember, we can't, we know the area of this is x squared, but I don't quite know how to graph that without a graphing calculator. So how could we graph this? Well, as you recall, I could break this up into a square that is x by x, and then another piece that's x by 7. So again, here we have x squared and we have 7x. And as you recall in the last video, I split this into two. So I had 7 halves and 7 halves. And I got rid of this 7 halves, and I moved it down to here. So I end up with a section of 7 halves by x, which is exactly what I had here. I just moved it. I didn't create anything. And so now to complete my square, or what should be a square, I need to figure out the area of this segment. The area of that segment, of course, is 7 halves squared. Since I added it here, I have to add it over here too. So I have to add a segment that is 7 halves by 7 halves. And I'm not quite sure if it's going to fit fit the mold here or not. But I still have to add it. I added it to one side, I have to add it to the other. Now I could say the area of this item is squared. And that must equal y plus 7 halves squared, because that's what I added to the other side. So in this case, I'm going to subtract the 7 halves squared from both sides. Minus 7 halves squared is 49 fourths. If you're kind of looking for a more rough number, that's squared, and this is minus 12.25. So now remember, this is in vertex form, which means I know my vertex is at negative 3.5, comma, negative 12.5. And I know, and this is y equals, right, because the y was there. And I know my a value is 1, so my jump pattern is plus 1, plus 3, plus 5, plus 7. So I can graph this. Go to negative 3.5, negative 3.5, negative 12.25, so roughly here. And then maybe a little higher, because 12.25. So that's my negative 3.5, negative 12.25. And so then I go right 1, up 1, left 1, up 1, right 1, up 1, 2, 3, left 1, up 3, right 1, up 1, 2, 3, 4, 5. And now without a calculator, I've graphed this equation. So there's lots I know about it now. I know roughly where y-intercept's going to be, where the x-intercept, I can find it more exactly. In fact, it's asking me for it, so let's find it. So, the vertex form I've written up here. The vertex is negative 3.5, negative 12.25. The line of symmetry, which you can see in this picture, it's where you have the same on the left and the right, is x equals negative 3.5. The y-intercept. Y-intercept is where x equals 0, so let's solve for it. Y equals 0 plus 3.5, squared minus 49 fourths. This is 7.5 squared, is exactly at 0. So in fact, by y-intercept, 0. My x-intercepts, on the other hand, can solve for those too because the x-intercepts are y equals 0. So this is 0 equals x plus 7 halves squared minus 49 fourths. So I'm going to add 49 fourths to both sides. 49 fourths equals x plus 7 halves squared. I take the square root of both sides. And here, of course, I get plus and minus 7 halves. Subtract 7 halves from both sides. This looks kind of weird because these are the same numbers. It won't always turn out to be this, but minus 7 halves plus and minus 7 halves. So that translated is either x equals negative 7 or 0. So my x-intercepts are at 0, 0, which I already knew, or negative 7, 0, which is right there. So those are my x-intercepts. My y-intercept 0, 0. Line of symmetry. I got all the aspects of this problem. So the key here was to complete the square allows me to graph it because it puts it in vertex form and allows me to find other items by isolating the squared quantity and then taking the square root.